This video is going to be a demonstration on Twitter troll detection. Through this project, we wanted to minimize the number of trolls people have to encounter when they use Twitter. To do this, we used artificial intelligence. Trolls have become an increasing problem online in the past few years as they spread misinformation and also offend people through provocative comments. So firstly, we start off by acquiring multiple datasets and compile them into a new dataset.
We converted these datasets from CSV files to JSON files using a Python script as we found it easier to work with. We used two datasets, one with 400,000 tweets for the final algorithm and the other with 30,000 tweets for creating a working algorithm, as it takes a lot more time to adjust our algorithm with 400,000 tweets. Both datasets have half troll and half non-troll tweets, which is later shuffled when training and testing the models.
Here we can see a few examples of data in a dataset. Each line is assigned a value of either 1 or 0 based off of whether it is a troll or not, respectively. In this particular case, 1 means a greeting and 0 means a farewell. We then pre-process the text in the dataset by removing special characters and keeping the alphanumericals. Then we encode the pre-processed data. Here is a simpler analogy to understand encoding. The encoder first takes the text and maps each word to a number. If the word already exists in this dictionary, then it will dismiss it. Each text is then converted into an encoded form of numbers. The next step in our project is training the algorithm using the encoded dataset. Here X represents the encoded data and Y represents whether the data is a troll tweet or not, where the value 0 is for non-troll and 1 is for troll. We initially split the dataset into training and testing data. The training data is used to improve the algorithm, and the testing data is used to check the accuracy of the algorithm. We then classified it into X-train, Y-train, X-test, and Y-test. The algorithm, when fed the training data, guesses whether it is troll data or not, and then improves itself by comparing its guesses with the actual value, or, in our case, Y-train. Now comes testing the algorithm. We do this by feeding the algorithm with X-test data upon which the algorithm gives predicted values. By comparing these values with Y-test, we get the accuracy of that algorithm.
After we understood the process, we converted it to Python code. If you want to access the code, go to the GitHub link in the description below. Keep in mind you will need to install the package in the readme.md in order to run the code properly. We can now run the code for accuracy results and save the encoders and models. We also use confusion matrices to better understand the accuracy. We will now analyze this data to see whether we can improve the model.
Initially, we used two encoding algorithms, bag of words and TF-IDF, but later on we switched to bag of words and removed TF-IDF as it takes longer to run and didn't show any improvement. Initially, SVM only gave us an accuracy of about 50%. We will see why this happened by looking at the confusion matrices. In these matrices, the columns represent the predicted values and rows represent the actual values. The square is darker with a comparatively lower number and lighter with a comparatively higher number. The one on the left is the SGD classifier optimizer, which we initially used. The reason why it failed was because it was only predicting the value 0 for some reason, giving us an accuracy of only 50%. But upon switching to linear SVC, there was a huge improvement in accuracy, as you can see on the right. In this case, it classifies the non-trolls perfectly, but struggles to classify the trolls. It now delivered accuracy equal to that of logistic regression and naive Bayes. Our top contender was neural networks with the highest accuracy so far. We even further improved its accuracy by 3% by adjusting some values. Here we have the final results. As you can see, logistic regression, naive Bayes, and support vector machine had an approximate accuracy of 75%. But neural networks topped the table with the highest accuracy of 98.45%. Keep in mind, since the algorithm is based on a random number generator, it may give slight variations every time we run the program. The accuracy may change based on different datasets as well.
We finally use an algorithm so we can load the previously saved models, which will result in an output of whether the tweet is a troll or not. For demonstration, we have inputted 5 tweets here and will output the results as ones or zeros. Keep in mind this text can be anything you input and isn't necessarily taken from the dataset.
Now that we have seen how useful artificial intelligence is in moderating trolls, let's see its drawbacks. When we consider the 98.45% accuracy in practical situations, we find out that approximately 93 tweets are misclassified every second. It's not much of a problem if a few trolls are misclassified as non-trolls, but the problem arises when innocent non-trolls are classified as trolls by the algorithm. Another drawback is the frequency of updates required to keep the model up to date by training it with the latest data. And the final drawback is that we cannot understand the actions of the AI algorithm as they come to conclusions using complex mathematics.
We have linked our GitHub repository and our research report in the description below.